A very warm welcome to all our viewers. I'm Anjali from Simplilearn, and today I'll be taking you through one of the most basic topics in Python, variables. So we'll have a look at what is a variable and then the various data types of variables. We'll also see the rules for naming these variables. After this, we'll check out some of the arithmetic operations we can perform on the integer and float type variables and the operations on the string type variables. And after this, we'll have a small exercise with strings. Also, stick on till the end for a short and fun quiz. So let's begin, guys. So here's a very simple statement, x equal to 100. A variable's definition is basically an entity of a program that holds a value. So in this case, x would be our variable and 100 would be the value it holds. To better visualize this statement, let's consider a box. Now, if this box holds a value, say 100, then the name we give to this box, which in our case is x, would be the variable name. And 100, that is the content within the box or within the variable, would be the value of the variable. Now, this is the basics of what a variable is. As we'll go through the various topics today, you'll have a better understanding of why we use variables and how to use them. So let's move on to the next topic, which is the various data types of variables. Before we move on to this, let me explain to you what data types are. If you have dealt with other programming languages before, you probably already know what data type is. But just in case you haven't, data type is basically the type of value that you assign to the variable. So in our previous example where we said x equal to 100, in layman terms 100 is a number. So the data type would be number. But when we come to programming languages, there are two types of numbers. There are integers and there are floats. Integers are basically numbers without decimal point. Floats are numbers with decimal point. Other than this, a very common data type that we have in Python and other languages is string. So string is any word. In technical terms, we call them a collection of characters. Python also has a few of its own data types, as we will see. So let's move on. So I'll move on to my Jupyter notebook. So the first data type that we'll be looking at is integer. As you saw in our previous example, x equal to 100 is an apt example for this. Let me run this statement. As you can see, there's no error. That means this assignment is proper. Now we'll check the type of this variable. So type, and within brackets, you enter x. Run this, and as you can see, the type is int. So int is the short for integer. Any number without a decimal point comes to int in Python. Now this is not the only way you can assign values to variables. You can also assign values to variables while simultaneously performing arithmetic operations on them. So 654 into 6734, enter. Now let's check out the type of this variable, which would be int again. Now if you print the value of this variable, you'll see that the value x stores is the product of these two numbers. So now let's move on to the next data type, which is float. X equal to 3.14. As you can see, this is a number with a decimal point. If you run this, there won't be any error. So this is a proper assignment statement. You print x and the value is printed. Now you print the type of x, run, and it's float. We'll move on to our next data type, which is strings. So string is any word, it's a collection of characters. So x equal to, and within quotes, so I'll type Simplilearn and run. So no error, print x, and the value of x is printed, which is Simplilearn. So guys, whenever you're assigning strings to a variable, it's important that you do them within quotes. Now you can do them within single or double quotes. I'll show you how it's done within single quotes. And the exact same output. So it does not matter whether you use single or double quotes. Now let's check out the type of this variable. Type x and str, which is a short form for string. So now that we had a look at integers, floats, and strings, let's move on to some of the data types specific to Python. The first one we look at is lists. So a list is basically a collection of values. So far we assigned a single value to a variable. With lists, we can assign multiple values. And this is how it's done. So give the variable name equal to, open square brackets, and within this you type your values. So 14, 67, 9. Run this, no error. Now let's print x and see what this results in. As you see, when you print x, all the values you stored within it is visible. Now let's check out the type of x. And the type is list. Now with list, since there are multiple values stored within a variable, you might be wondering how you can extract a single value. So this is simple. Each value in a list has an index. So you always start with 0. This is the 0th position, first position, second position. So if you want to extract 14, then you type print x0 and that will display 14. If you want to print the last value, print x2, because we start from 0, so this is 1 and this is 2. So that should print 9. Great. Now we'll change the values which are stored within the list. So if I say x2, which right now is 9, but I want to change this to 67. So that is a simple statement how you can do so, and run. Now let's see what x holds. So when you just type x, you're printing every value within x, and when you give a particular number within the square brackets with x, you're printing the value at that particular location. So print of x, run. And as you can see here guys, previously x held 14, 67, 9. Now it holds 14, 67 and 67 again because we changed x of 2 to 67. So now that we are done with lists, we'll move on to another data type in Python. This is called tuple. So with tuple 2, it's about the same thing. You can store multiple values in a single variable. The syntax for doing so though is slightly different with tuples. So instead of square brackets, you now have round brackets. And within that, you type in your values. So I'll just put 4, 8, 6. And let's print x. So all the values within x is printed. Now let's check the type of x. And the type gives tuple. So you might be wondering what is the difference between list and tuple. Now the core difference between list and tuple is that tuples are immutable. So what I mean here is that in case of tuples 2, you access each value within it in the same way you do with lists. So if I want to access the value 8 in x right now, I'll just give x within square brackets 1. Print this. And it outputs 8. But now, if I want to change this value, so the way of doing that, as we saw with lists, is x of 1 and the value I want to change it to. So let's say 5. And I run this. We get an error. So you cannot change the values in case of tuples. Once you have stored the value within the variable for a tuple, it remains that way right till the end. And in technical terms, this means that tuples are immutable, while lists, for which you can change the values, they are mutable. So now we have something slightly different. When we deal with files, we need a variable which points to a particular file. So in general, these are called file pointers. The advantage of having file pointers is that when you need to perform various operations on a file, instead of providing the file's entire path name or the file's name every time, we can just assign it to a particular variable and use the variable instead. So this is exactly the advantage variables have with all other values too. But the syntax for doing so with files is slightly different. So I give x equal to open and within brackets, open quotes, enter your file name. So I want to open, say, a file called variable_com, and this is IP Y and B. So it's my Python notebook. And the mode I'd like to open it in. So R. Let me run this. No error. So it's fine. This kind of an assignment is completely legit. Now we'll check the type of X. So as you see here, the type for X is _io.text io wrapper. So in Python, this is the particular type assigned to this variable. But in general terms, you can refer to them as file pointers. Now suppose you want to assign values to multiple variables. What you can do here is, instead of having statements like x equal to 5, enter, y equal to 10, enter, z equal to 7, instead of having 3 such statements, delete, open bracket, x, y, z, within bracket, equal to 5, 10, 7. And this works exactly the same. So now if you print x, y, and z, you'll see that they have been assigned their respective values. Of course, the number of variables and the number of values on either side should match. So if you put x equal to y, so if you give x comma y equal to 5, 10, 7, this would result in an error because you have only 2 variables on your left hand side while you have 3 values on your right hand side. Now suppose you want to assign the same value to multiple variables. In that case, you can do, now suppose you want to assign a value to multiple variables. Say x equal to 1, y equal to 1, z equal to 1. A short form to this, as you saw previously, would be x comma y comma z equal to 1 comma 1 comma 1. But then again, you'll have to type the same value 3 times. Instead, what we can do is x equal to y equal to z equal to 1. And this would work perfectly fine. So if I print the value of x, y, and z now, they all have the value 1 stored within them. So we have covered the various data types in Python and how you can assign values to a variable in multiple ways. We'll next move on to the various rules for naming the variables. Now there are certain rules that you must follow while naming the variables. We'll go through each of these rules, and simultaneously I'll also demonstrate to you in our notebook the validity of each variable. So our first rule is variable name must begin with an alphabet or an underscore. So let's move on to our notebook. So ABC equal to 100. This should be valid because it starts with an alphabet. At the same time, underscore ABC would also be valid. So if the variable starts with an alphabet or an underscore, it's a valid name for the variable. But if we say 3A equal to 10, this would result in an error. Of course, because the variable name starts with a number, and this is invalid. Same way, we cannot start the variable name with a special character other than underscore. So if I say @ABC, this would also result in an error. As you see, the error is invalid syntax because that is the invalid syntax for a variable name. Let's now look at the second rule for naming variables. The first character can be followed by alphabets, numbers, or underscore. So our first character must be an alphabet or an underscore, and after this first character we can have alphabet, we can have numbers, or we can have underscore. So back to our notebook. By the second rule, 100 should be valid as it is, and if we put underscore, which is a valid starting character, 984, so our first character is followed by a letter, 3 digits, and then another underscore. This should also be valid because at the end of the day it only consists of numbers, letters, and an underscore. However, if our variable name is A9967, few digits, and then a $sign, would this work? Well, no, this would result in an error, invalid syntax, because as already mentioned, For variable names, the only special character you can use is underscore. What about XYZ -2? Again, this would be invalid because it includes a special character that is not underscore. Can't assign to operator. Let's have a look at our third rule. Variable names are case sensitive. So what case sensitive means is that small letters and capital letters are treated differently. So let's move back to a notebook and say I assign a value 100 to a variable A100, small a, and I assign another value 200 to a different variable, capital A100. So as you see here guys, between these two variables, the only difference is that the first variable has a small a and the second variable has a capital A. Let me just execute this. If I print the value of A100 and capital A100, you'll see that both these variables are recognized as completely different variables. They have their individual values. So now that we established that variables are case sensitive, we can also say that Python itself is a case sensitive language. Now our final rule is that reserved words cannot be used as variable names. Now if you have gone through any other languages like C, C++, Java, you know this is a common rule among all of them. You cannot use words which have special meaning to the language as variable names. So some of these words are break, class, try. You have other words such as continue, while, which is a loop, or if, which is a statement, a conditional statement. So let's go back to our notebook and see how assigning values to these reserved words can result in errors. So if I give break equal to 10, that would be an error. Similarly, class equal to 5 would result in an error. Try equal to 100 would also result in an error because these words, break, class, try, have special meaning to Python. And with that, we cover the various rules for naming variables. The next thing we'll check out is the arithmetic operations that you can perform on these variables once you have stored integer values in them. Also perform various arithmetic operations with variables that store integer or float values. So let's have a look at some of these operations that we can perform. We'll start with initializing two variables. So x equal to 20 and y equal to 10. And now we'll perform our operations with these two variables. So first let's check out how addition works. Result equal to x plus y. So result is a new variable and it should store the value of x plus y. Let's print this out. And as you see, x plus y equal to 30. So now result stores 30. Similarly, we can perform subtraction. We'll print this out too. So 20 minus 10 is 10. We can also perform multiplication. We use asterisk for the multiplication sign. So 20 into 10, that's 200. Next, we'll check out division. So as you can see here, in case of division, the result is not an integer but rather a float. If you want your result in integer, what you can do is instead of putting just one slash, you can apply two slashes. So x / y. And print the result. And there you go. Now you have the result in integer. So in this particular case, since 10 completely divides 20, the requirement of the double slash is not very visible. But if we do division for numbers that do not divide each other completely, for example, if we have result equal to 2 by 3 and we print the result, we get 0.66 and so on. But if we give double slash here and run this, we get the result as 0. So in a lot of cases, the result from double slash makes way more sense than from single slash. So this is an extra benefit you have with Python, which is not present in many other languages. We also have the modulus operator here, which gives the remainder rather than the quotient. So if I say x mod y, it'll give me the remainder of the division from x by y. And the remainder is 0 because 10 completely divides 20. On the other hand, if you do want to see the remainder, you can give numbers such as 3 by 3 mod 2 and then print the result. And as you see, the remainder of this operation would be 1. Now, so far we saw arithmetic operations with integers. All these operations can also be performed with floating point numbers. So if your x value is 3.14 and your y value is 5.7, let's just perform one operation using the new values of x and y to see what it looks like. So let's say result equal to x by y, print result, and there's your quotient. So arithmetic operations work both with integers and floating point numbers. Next, let's check out some of the operations you can perform on string variables. As I mentioned earlier, strings are basically a collection of characters. So let's look at a few string operations. First, we'll initialize a string variable. So var equal to Simplilearn, and we'll perform all our operations on this var variable. Now the first thing we'll do with this string variable is we'll see how we can extract each character in string. So just like in case of list and tuples, every character in your string has an index and it always starts with 0. So the first character is at location 0, second at 1, third at 2 and so on. So if you want to extract the first character of your string, which is s in our case, we just do var of 0. And as you see, s is printed. Similarly, if we want to extract the fifth character of our string, we'll put var of 4. So if you want to extract nth character, your index for it would be n minus 1 because we start our index from 0. And that prints L. So as you can see here, s is 0 and then we have 1, 2, 3, 4 and that is L. So now that we learned how to extract a single character, let's see how we can extract multiple characters from the string. Suppose I want to extract the first 3 characters. In that case, I would say var of the first 3. So my starting character would be at 0. So if I want to extract the first 3 characters of my string, what I'm basically saying is that I want to extract the character at the 0th, 1st and 2nd position. Then I'd say print of var of starting from the 0th location up to the 3rd location. We say 3 and not 2 because the last index is always excluded. So if I put 2 here instead of 3, then only the 0th and the 1st character would be printed. So I want my first 3 characters to be printed. So var of 0 to 3, and I'll run this. And as you see, the first 3 characters have been printed, capital S followed by IM. Now if you want to start from your first character, you can also just ignore the 0. So you can say var of :3. That is, we are not typing the 0 in this case. It's automatically understood that you start extracting from the first character when you miss out the 0. So you run this and as you see, it's the same result. Now if you want to print the character starting from the 5th location until the end of the string, you can go with print of var of 5th character, so 5 and up to the end. In this case, you do not need to mention the last index. You can just leave it blank and it's automatically understood that you're printing till the very last character of your string. And as you see, from your 5th index to the very last character has been printed. Now suppose you give var of 0 to 20 and it's pretty obvious that you do not have 20 characters in this particular string. So you do not have 20 indexes. So what do you think would happen if I do 0 to 20? Well, the entire string is printed. So although we have only 11 characters in our string and we have given the ending index as 20, this does not result in an error, just our entire string gets printed. Now if you want to find out the length of your string without actually having to count it manually, you can use the function len of var. Len is an inbuilt function in Python. Now run the command and as you can see, we have 11 characters in our string. So those are the basic operations you can do with a string variable. I hope this is very clear to you, as in the end we have a small quiz which uses some of these concepts. So now that we have gone through the various concepts of variables, let's have a small exercise where we'll be using string variables. So we'll have two strings. One string says it's Sunday and the other stores have a great day. Using only these two strings, we need to build a third string which says it's a great Sunday. So let's have a look at how to do this. We move back to our notebook. The first thing to do is we store our two source strings in separate variables. So let's have variable var1 which stores our first string. It's Sunday. And we have the next variable var2 which stores our second string, have a great day. Now using these two strings, we create our third string which is var3. So first let's run these two statements. So now var3 needs to store it's a great Sunday. The word it's comes from var1. So var1 and it starts at the first location. So 0, which we can ignore because it's automatically assumed to be 0. And we require all the characters in var1 from the 0th position until the position just before our capital S of Sunday. So that would be 0, 1, 2, 3, 4. So our fourth position is the blank space. Since we want to include the blank space too, we give our ending index as 5. Now the next part of our string, it's a great Sunday, needs to include a great from var2. So var2. So the next part of our string is a great, and a great comes from var2. Now this subscript starts from the 5th position in var2. So our starting position would be 5. And at the 12th position in var2, we have the space that comes after great. Now we need to include the space too. So we'll go with our ending index as 13. And finally, our last word of it's a great Sunday, which is Sunday, will come from var1. So var1 and the word Sunday starts from the 5th location in var1. So our starting index here would be 5. And we'll take the entire string from the 5th location. So we leave the ending index empty. And that's it. So let's run this. Now let's just check if what we did so far is correct. So we'll print var3. And yeah, that's perfect. As you can see, we have it's a great Sunday in var3, which is exactly what we wanted. So now a short quiz for you. So if you're familiar with other programming languages, but for those who are completely new to programming languages, definitely try this out. So we have a variable a which holds a value 100, and we'll have another variable b which holds a value 200. Now the task is we want b to hold the value 100 and a to hold the value 200. So basically you're swapping the values between these two variables. So give this a thought and post your answers in the comment section below. We'll give out the answers soon enough. And with that, we come to an end of Python variables. I hope you like this video. If so, please hit the like button. Also subscribe to our channel if you haven't yet. This is Anjali signing off. Have a great day.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.